I'm Dr. Gorgon, and today we're going to briefly review how to compile on a Linux machine using command line GCC. I already have a file that is set up called helloworld.c. It can compile, and if I just want to use GCC in order to do that, that's fine. I will use GCC helloworld.c. If nothing happens, great, that means that it compiled correctly. If I want to rename that file, I can, but by default, that is going to produce a file named a.out. When we run that, it's going to end up producing our output from a program, which includes a random number that's generated from 1 up to 500. So we can just create a file called a.out, but we could also rename our output file so that it is hello world without the .c. You don't want the .c on there. That creates a fatal error if you try to do that. We're going to go ahead and compile that way, and this is going to produce that output file named hello world that's in green. When you go to run that, it is going to be successful. So if I don't want my a.out file anymore, I can remove it. That's fine. And now I just have hello world.c and hello world. So I can get a little bit fancier with this though. I want to show you today that there are 4 different stages to the compilation process. The first one is the preprocessor. So if we want to see the output from the preprocessor, we would use gcc-e with our hello world.c. That's going to produce all of that output to the command line. We don't really want that. So we're going to redirect that so that this becomes a hello world.preprocessor file. And now if we wanted to go take a look inside of the hello world preprocessor file, we can. Basically, this contains all of the information that was previously in the header files that were included, and anything that is a macro will end up being removed and replaced during the preprocessor stage. The second piece of the compiler is the compiler. So this is the piece that actually turns the C code into assembly code. So we can stop it after the compiler piece runs if we use -s. This produces a file called helloworld.s, and if we go take a look at that, it has assembly code in it. Isn't that exciting? The third piece turns the assembly code into machine code. That is called the assembler. The assembler produces object code, but it can't yet be run. So we actually do this a fair amount of time when we use C coding, because anytime we work with a library, usually we create a header file, and then we also create a .c file that completely implements everything that is defined inside of that .h file. So the reason why that's useful is because this produces an object file, that hello world.o file. If it's a library and somebody else includes the header file with that, your code does not have to be recompiled. It just has to be linked in that next stage of the compilation process. So the third is the assembler. It produces this hello world.o file. And if we tried to edit that hello world.o file, well, it's not human readable, mostly. So then the last piece. If we go all the way to the end of the compilation process, that's what we've done previously. We're just going to use GCC with hello world.c. It goes all the way through the compilation process. We can rename the output into something that is an executable binary file. It runs, as long as there are no errors showing. I'll see you next time. This was Dr. Gorgon. Hopefully we'll have great new content for you next time.